Hello everyone, today we see binary phase shift keying. It is a digital modulation technique that encodes binary data by shifting the phase of a constant frequency carrier signal between two states 0 and 180 degree. In binary phase shift keying, a pair of signals S1 of t and S2 of t are used to represent symbols 1 and 0 respectively. S1 of t is given by under root 2 EB by TB cos 2 pi FCT. It's for symbol 1. S2 of t is equal to under root 2 EB by TB cos 2 pi FCT plus pi. It's for symbol 0. S2 of t is equal to minus S1 of t. Here TB is the bit duration, EB is the transmitted signal energy per bit. FC is equal to NC divided by TB, where NC is a fixed integer. Signal space diagram. Phi 1 of t is equal to S1 of t divided by S11, where S11 is equal to root EB. EB is integral 0 to t S1 square dt. Here we substitute the value of S1 of t. S1 of t is root 2 EB by TB cos 2 pi FCT divided by root EB. Here EB cancel and we get under root 2 divided by TB cos 2 pi FCT. The transmitted signals S1 of t and S2 of t in terms of phi 1 of t are given by S1 of t is equal to under root EB phi 1 of t. S2 of t is equal to minus root EB phi 1 of t. Signal constellation consists of a message points. N is equal to 1, M is equal to 2. S11 is equal to 0 to TB, S1 of t, phi 1 of t. Here we substitute S1 of t. S1 of t is root EB phi 1 of t. Here phi 1 of t is equal to 1. S11 is equal to root EB. Similarly, S21 is equal to minus root EB. Signal vector SI is equal to S11 and S21. The signal constellation is message point 1 EB for message point 2 minus root EB. Generation and detection of PSK signal. We have two components, transmitter and receiver. In transmitter we have polar NRZ level encoder product modulator. Polar NRZ level encoder represents the incoming binary symbols 0 or 1 by amplitude levels plus root EB and minus root EB respectively. Product modulators, it multiplies the output of polar NRZ encoder by the basis function phi 1 of t. Here phi 1 of t is carrier of the binary FSK signal. Receiver. In receiver we have two components, correlator and decision device. Correlator, it is the received signal x1 of t with basic function phi 1 of t on a bit by bit basis. Decision device, it compares the correlated output with zero threshold, assuming zeros and ones are equiprobable. If x1 of t is greater than the threshold, decision is in favor of symbol 1. If x1 is less than the threshold, the decision is taken in favor of symbol 0. If x1 is 0, the decision is taken randomly.